Welcome everyone. We are going to do Module 1, Homework 2. So, here's our first question. How many different numbers make this equation true? Well, the answer, I hope you can see, is just one number. The only number that makes this true is the number 3. How many numbers make this one true? Well, this is asking what numbers are larger than 6, 7, 8, 9, 10, 11, 12, and so on. There is an infinite number of numbers that make that true. How many different numbers make this one true? Well, we're looking at all the numbers between 1 and 3. We're including 1, but we have to be strictly less than 3. So 1 makes it true because 1 fits that. 2 makes it true because 2 is between 1 and 3. 3 does not make it true because we're saying the number has to be less than 3. So we're not including 3. I'm going to put a little open circle to indicate that we're not actually including 3. So would you say the answer is two numbers, 1 and 2? Well, that would not be right. Those aren't the only numbers between 1 and 3. There's also 1.5, which is right there. There's also 2.1, which is right there. There's also 2.9, which is right there. Every number between 1 and 3 makes that true. Every decimal, every fraction, everything starting at 1 and going all the way up to 2.99999 like that, but not including 3. So there's an infinite number of numbers that make that true. So if we're solving an inequality, we can get an infinite number of answers. We need a way of writing that infinite list of answers. One moment here. So since we're getting infinitely many solutions to some inequalities, with all of the answers in a row, all the numbers in a row from 1 up to 3, for instance, we're going to use something called interval notation as a shortcut way of writing our answers. Okay, so here's how we write it. Suppose, for instance, the answer to a problem is all the numbers larger than 6. Pictorially, that means from 6 out to infinity. Not including 6 itself, though. So again, I'm going to put a little open circle on 6 to indicate we're not including 6 itself. The way you write that interval notation is you look at the shaded interval. There's a 6 on the left side of it, and on the right side of it goes to positive infinity. Interval notation, you take whatever number is on the left, you put it on the left. You take whatever number is on the right, you put it on the right. Be sure you don't reverse those. Don't put infinity with the 6 on the other side of it. You put a parentheses on the 6. I'll explain more about that later. And you put a parentheses on the infinity. The rule is infinity always gets a parentheses. The number will either get a parentheses or a bracket. I'm going to oversimplify things, but it's good enough for our purposes. If you have something like that with an equals on the bottom, you put a bracket. If you have something like that without an equals, you put a parentheses. So because we don't have an equals on there, you put a parentheses. This means all the numbers larger than 6 and all the way up to infinity. That's called interval notation. If we were talking about all the numbers starting at 6 and going up to infinity, but if we actually included 6 as one of the answers, which is what this is saying, in interval notation, that would be bracket 6, comma, infinity. Now, let's look at this one. People often get this wrong. This means the same as that. Since it means the same thing, and we just saw that answer above right there, this is how you would write that using interval notation. Let's take a look at this. This means all the numbers between 1 and 3, including 1 and not including 3. So it means we're including the number 1, we're including all the numbers up to there, but we're only going as high as 2.9999999, essentially. We're not going all the way to 3. Since you have an equals on that, the 1 gets a bracket. Since you don't have an equals on that, the 3 gets a parentheses. This is a shorthand way of saying what's in this picture, and this again is called interval notation. Now, just a note about these number lines. This is the way that I like to draw a number line, but this is not the way your homework will usually show it to you. On a number line, whenever you're including a number, they put a bracket instead of a closed circle. And when you're not including a number, they put a parentheses instead of an open circle. I don't really like that, but if that's the way they do it, I don't have any choice. Okay, when you are solving an inequality, it pretty much follows the rules that you know so far, although more advanced inequalities are different, but we don't have to worry about that. The main different rule is that when you're solving, if you multiply both sides of it or divide both sides of it by a negative number, you have to reverse the inequality. Let me show you what I mean. We're going to solve this. We're going to solve negative 2x plus 7 is less than 9. I will subtract 7 from both sides. That gives me negative 2x on the left. That gives me 2 on the right. I do not reverse the inequality because I subtracted. That doesn't reverse an inequality. Now I'm going to divide both sides by negative 2. That gives me x on the left. That gives me negative 1 on the right. And since I divided by a negative, I take my inequality symbol and I switch it around. So the answer to that is all numbers for x larger than negative 1. So there is negative 1. So the answer is everything beyond negative 1. And the way you probably will see it in the homework, instead of the open circle I'd like to show, they put a parentheses on there. In interval notation, you ask yourself, what's on the left side? Negative 1. What's on the right side? Infinity. You put a comma between them. Infinity always gets a parentheses. And because we have greater than and not greater than or equal to, you put a parentheses there. So that's the answer in interval notation. Now there's something called set builder notation, and I'm just going to keep this very simple. Set builder notation, you basically have a little setup like this, and in there you put the fact that x is greater than negative 1. Now, how do you read that? Well, let's take a look at what's underneath the box here. That is read the set of all values for x where x is greater than negative 1. Okay, moving on. We're going to solve this inequality. To solve this, I'll first simplify the left. That's 4x minus 20. I'll simplify the right. That is 6x minus 2. I will then move the 6x over to the left. You know what? I'm going to do this a different way. I can, and it's fine. I'm going to subtract 4x from both sides. That's going to give me negative 20 is greater than or equal to 2x minus 2. I'm then going to add 2 to both sides. When I do that, I will have negative 18 is greater than or equal to 2x. Then I will divide both sides by positive 2. Since I'm dividing by a positive, I don't switch the sign. So I'm going to have negative 9 on the left. I'm going to have x on the right. Now, I showed you something like this before, but I didn't really comment on it. Anytime your final answer has an x on the right, it's helpful to rewrite that. And the way you rewrite it is you just flip everything around. You put the x on the left, you put the negative 9 on the right, and you switch the sign. This and this are both saying the same thing. They're both saying all the numbers less than or equal to negative 9. On a number line, let me see, are they asking for a number line? Yes, they are. So let me put on the number line down there. I should copy this down. One moment, my screen's going a little crazy. X is less than or equal to negative 9. Let me copy that down. x is less than or equal to negative 9. On a number line, we would show where negative 9 is, wherever you want to put it. It's less than or equal to, so that gets a bracket when you have less than or equal to in the equals part of it. It's the stuff less than it, so it goes all the way down to the left, which is where negative infinity is. To write it in interval notation, you take whatever is on the left, you put it on the left. You take whatever is on the right, you put it on the right. The infinity always gets parentheses, like I said earlier. And because of the equals part of this, we get a bracket, not a parentheses. And the set builder notation way to write this is to put in x is less than or equal to negative 9 inside that little set. And again, if you want to see how that's read, what that set builder notation is telling you, it's telling you it's the set of all values for x where x is less than or equal to negative 9. Okay, we're going to solve this one. I'm going to show you one way to solve it. There are multiple ways to solve it. One way to solve it is to multiply all the terms by 6. Now, since I'm multiplying fractions by a whole number, it's good to put a 1 underneath this to treat it as if it's a fraction. The 2 goes into 6 3 times because you can cancel a denominator with a numerator when you are multiplying. Denominator with numerator gives me 2. Denominators cancel each other. On the left, I get 3. In the middle, I get 4. And on the right side of this, all I have remaining is x. This gives me this. Remember, if the x lands on the right side in the final part of the answer, you should switch this all around. So this is the same as saying x on the left, 7 on the right. You switch that around and you get that. This is the same as saying x is greater than or equal to 7. So that's our answer. On a number line, you'd find 7. And since it's greater than or equal to, you put a bracket. And since it's greater than, you're showing to the right. The right is where infinity is. So in interval notation, 7 on the left, infinity on the right. Infinity always gets parentheses. And if you have the equals, you put a bracket on the 7. And this would be the set builder notation answer. Okay, I'm going to solve this guy. I'm going to do the same idea as the last one. I want to get rid of all my fractions. To get rid of fractions, I got to get rid of the denominator. If I multiply everything by 8, so 8 over 1, 8 over 1, and this is just a whole, this is not a fraction, so I'm going to multiply that by 8. There's no need to put the 1 underneath that. Denominator cancels numerator, I get 4. Denominators cancel each other. On the left side here, I get 4 times in parentheses negative x plus 2. Then I have the 1 minus 5x, but that whole thing is being subtracted. So I put it in parentheses, is greater than or equal to negative 8. By the way, you might have been thinking I should reverse the signs because I multiplied. No, you only reverse the sign if you multiply by a negative, and we multiplied by a positive here, so that doesn't cause any trouble. Now, distributing, I get negative 4x plus 8. Distributing the minus, I get minus 1 plus 5x is greater than or equal to negative 8. Just cleaning up my handwriting a little bit. Okay, combining like terms, I get x. Combining these together, I get plus 7 is greater than or equal to negative 8. I'll subtract 7 from both sides. I'm going to get x is greater than or equal to, excuse me, that's horrible, greater than or equal to negative 15. There's my answer. On a number line, that means starting at negative 15, it's everything greater than it, and also including 15 itself, so you put a bracket. The interval here goes from negative 15 on the left to infinity on the right. So I get negative 15 to infinity, parentheses on the infinity, and because of the equals part of this, bracket on the negative 15. I think I'll skip the set building notation. We've done enough of those. Okay, the next thing is called compound inequalities. Compound inequalities look like this, and your goal is to get the x by itself in the middle. And a key thing is that anything you do to one part of this, and it's got 1, 2, 3 parts to it, you must also do to the other 2 parts. So our goal is to get the x in the middle. We have negative 2 is less than or equal to 3x minus 5, which is less than or equal to 7. The best first step is to add 5 to everything. When I do that, I have 3 on the left, I have 3x in the middle, and I have 12 on the right. We're trying to get the x by itself here. To get it by itself, I will be dividing by 3. I'm dividing by a positive, so I don't reverse the signs. On the left, I get 1. In the middle, the 3's cancel and I get x. And on the right side, I get 4. So the answer to this is all the numbers between 1 and 4, including the 1 and including the 4. It didn't say how to write the answer. I'll just do it in interval notation. On a number line, that would be everything from 1 to 4 shaded. I'm putting brackets because of these equals that we have here. And the interval notation would be bracket 1, 4, bracket. That would be the interval notation answer. Okay, this one here, 1 is less than or equal to 2/3 x plus 3, which is less than or equal to 4. I'll subtract 3 to get rid of that, so I'll subtract 3 on all the parts. That gives me negative 2 is less than or equal to 2/3 x, which is less than or equal to 1. Now, the next step I can actually do in one step instead of the 2 I'm going to do it in, but I think the 2 will be less confusing. I don't want a fraction here. Because of that, I'm going to multiply this by 3/1 so that the 3's will cancel. But if I multiply by 3 in the middle, I got to multiply by 3 on the left and by 3 on the right. I could write 3/1 in those cases, but there's no need because they're not fractions. On the left, I get negative 6. In the middle, the 3's cancel. I get 2x. On the right, I get 3. I'm still not done because x isn't by itself. So I'll divide everything by 2 to get the x by itself. When I do that, I'll have negative 3 on the left. The 2's cancel. I'll get x in the middle. And on the right side, I will have 3/2. That's my answer in interval notation. That would be bracket negative 3, positive 3/2, bracket. Okay, we're going to solve this one. The first thing I'll do with this one is try to get rid of the fraction. So I'll multiply everything by 4. 4/1 times the fraction, 4 times that one, and 4 times that one. On the left, I have negative 20. In the cancel, and that leaves me with just negative 3x plus 1. On the right, I have 8. I will then subtract 1 from all 3 sides to get negative 21 is less than or equal to negative 3x is less than or equal to 7. I'm then going to divide everything through by 3. Give me a moment. I see something that looks a little bit weird. I don't see anything wrong with it. Okay, I guess it's fine. So I'm going to divide everything through by negative 3. Those cancel. I get x. Here, I get positive 7. And here, 7 over negative 3 is negative 7/3. I divided by a negative, so the signs get reversed. Again, something looks a little bit off to me, but I don't see a problem. It seems fine. Okay. So we're between -7/3 and 7. Be careful. -7/3 is on the left. 7 is on the right. We do have the equals on the bottom of each of these. So both of them are going to get brackets. So that's a picture of the answer with, of course, the middle shaded. And in interval notation, it is -7/3 to 7 with brackets on either end. So that is the solution to that one. Just one more moment. Just something looks weird. I'm just double checking to see if I see a problem, but I don't see anything. I hope that that is right. So that is the answer to that in interval notation. We got a couple more things to do here. We're going to write this using interval notation. Well, all that means is this. This, as a picture, is all the numbers greater than 2. So that would be parentheses 2 to infinity. Done. This, as a picture, is all the numbers between 1 and 3. Because of the equals, we have a bracket on the 3. Because we don't have an equals, we got a parentheses on the 1. And so it's parentheses 1, 3 bracket. And those are those two answers. And I believe that is the end. Yes. So this is the end of Module 1, Homework 2.